Okay, so you're going to go ahead and pause the video and try this problem on your dry erase board or scrap paper. You want to use a difference identity to evaluate the sine of 13 pi over 12 for its exact value, showing all work. Okay, you can resume the video when you're ready to go over that together. So we're going to start by changing these denominators for the special angles on the unit circle to 12s, and pi over 6 is 2 pi over 12. Then pi over 4 is 3 pi over 12. But rather than writing out all the pi over 12s, I'm just going to make a note to myself of what those numbers in front of the pi in the numerator are. So 2, 3, then 4, 6, 8, 9, 10. Then this would be 12 pi over 12, 14 pi over 12, 15 pi over 12, 16 pi over 12, 18 pi over 12, 20, 21, 22, and then 24 pi over 12. So if I want to use a difference identity, then I need to find two of these that subtract to equal 13. And 21 minus 8 is 13. So we would be using 21 pi over 12, which is 7 pi over 4, and 8 pi over 12, which is 2 pi over 3. So I'm going to take my sine of 13 pi over 12 and rewrite that as the sine of 21 pi over 12 minus 8 pi over 12. And simplifying or reducing those denominators, we end up with 7 pi over 4 minus 2 pi over 3. Those will be the two special angles on the unit circle that we're going to use with this identity. Okay, looking at our difference identity for sine, right, we're using the minus, so that's going to be the sign of the quantity A minus B, which means our corresponding symbol then is the bottom here, which is also a minus. So this is going to be the sine of A, which is 7 pi over 4, times the cosine of angle B, 2 pi over 3, then a minus cosine of angle A, 7 pi over 4, times the sine of angle B, 2 pi over 3. Made that too big. 2 pi over 3. Okay, now we can substitute in each of these values for the different trig expressions. So sine of 7 pi over 4 is looking for the y coordinate at that angle, and that is a negative square root of 2 over 2. That's being multiplied times the cosine of 2 pi over 3. That's the x coordinate at 2 pi over 3. And that's a negative 1/2. Then we subtract the cosine of 7 pi over 4 is the x coordinate at that angle. That's a root 2 over 2. And that's times the sine of 2 pi over 3. That's the y coordinate at 2 pi over 3, square root of 3 over 2. And we're going to simplify. So we'll have a negative, and a negative is a positive square root of 2 over 4. then square root of 2 times square root of 3 is square root of 6 over 4. And then these both have a common denominator of 4, so we can combine these fractions by subtracting the numerators. And we'll have square root of 2 minus square root of 6, all divided by 4. We can check that in the calculator in radian mode by evaluating the sine of 13 pi over 12 and comparing that decimal to our answer, square root of 2 minus square root of 6, all divided by 4, and our decimals are equivalent, so it checks.